Welcome to ICS Mahesh PU College, Dharwad. In last sessions, we have seen few examples. Today, also we solve few more examples. Next example is solve the LPP graphically, maximize and minimize z equal to x plus 2y, subject to the constraint x plus 2y greater than or equal to 100, 2x minus y less than or equal to 0, and third constraint is 2x plus y less than or equal to 200, and non-negative constraints x comma y greater than or equal to 0. Here our objective function is z equal to x plus 2y, and we have to find the maximum and minimum value of the z. And let us see the solution. Considering the first equality, that is x plus 2y equal to 100. When we substitute x equal to 0, we get y equal to 50, and when y equal to 0, we get x equal to 100. Now we need to consider second equality. When we substitute x equal to 0, we get y equal to 0. On other hand, when y equal to 0, we again get x equal to 0. Hence, we need to consider an arbitrary point, that is when x equal to 50, we get y equal to 100. And next, third equality, that is 2x plus y equal to 200. When x equal to 0, we get y equal to 200, and y equal to 0, we get x equal to 100. Let us consider an xy plane. First point is 0 comma 50. Second point is 100 comma 0. Joining these 2 points, observing the first inequality, that is x plus 2y greater than or equal to 100. To find the region, we need to substitute x equal to 0, y equal to 0 in the first inequality. We get 0 is greater than or equal to 100, which is a false result. Hence, we need to shade away from the origin. And second point is, that is 0 comma 0, and an arbitrary point 50 comma 100. Joining these 2 points, here we need to consider an point which not lying on the given line, is nothing but the point which not lying on the second line. Hence, I am considering here a point that is 50 comma 0. Hence, we need to substitute x equal to 50 and y equal to 0 in the second inequality. When we substitute x equal to 50 and y equal to 0, we get 100 minus 0 is less than or equal to 0. 100 minus 0 is equal to 100, hence 100 is less than or equal to 0, which is a false result. Hence, shading away from the origin. And third inequality is points, that is when x equal to 0, y equal to 200, that is 0 comma 200, and next point is 100 comma 0. Observing the third inequality, substituting x equal to 0, y equal to 0, we get 0 is less than or equal to 200, which is true answer. Hence, we are shading towards the origin. Hence, common region is yellow shaded part. Therefore, here the corner points are 0 comma 200, 50 comma 100, and 0 comma 50, and there is one more point. We need to find that point by solving the equations of those 2 lines. Hence, consider those 2 lines equation. What are those equations? 2x minus y equal to 0, 2x plus y equal to 200. Hence, here plus y minus y get cancelled. We get 4x equal to 200, x equal to 50. When substituting x equal to 50 in any one of the equation, we get y equal to 100. Therefore, C is a point 50 comma 100. And one more point we need to find, that is x plus 2y equal to 100 and 4x minus 2y equal to 0. How it is 4x minus 2y? Here in second inequality, we are multiplying it by 2. Therefore, we get 5x equal to 100 and x equal to 20. By substituting x equal to 20 in any one of the equation, we get y equal to 20. Hence, next point is d of 20 comma 40. Therefore here you are observing that the corner points are a of 0 comma 50, b of 0 comma 200, c of 50 comma 100 and d of 20 comma 40. Let us find the maximum and minimum value of given LPP, that is a of 0 comma 50 we obtain z equal to 100. When b of 0 comma 200 we get z equal to 400, and c of 50 comma 100 we get z equal to 250, and last corner point is d of 20 comma 40 we obtain z equal to 100. Hence by observing the table we can say that the maximum value of given LPP is 400 at the point b of 0 comma 200, and minimum value of given z is 100 at a of 0 comma 50 and d of 20 comma 40, and at all the points on the line joining a and d. This is the solution of the problem. Let us move to the next problem, that is solve the LPP graphically, maximize z equal to minus x plus 2y subject to the constraint x greater than or equal to 3 and x plus y greater than or equal to 5, and third constraint is x plus 2y greater than or equal to 6, and non-negative constraints are x comma y greater than or equal to 0. Here our objective function z is to maximize, is nothing but we need to find the maximum value of given LPP. Hence see the solution. Considering the equality, that is x plus y equal to 50. Similarly we need to find the values of x and y, that is when x equal to 0 we obtain y equal to 5 and y equal to 0 we obtain x equal to 5, and next equality is x plus 2y equal to 6. When we substitute x equal to 0 we get y as 3 and y equal to 0 we get x equal to 6, and third equality, that is x equal to 3. Here x equal to 3 is a line which is parallel to the y-axis, is nothing but which is perpendicular to x-axis. Hence the points are when x equal to 3 it is understood that y is equal to 0. Consider an xy plane. First point is 0 comma 50, second point is 5 comma 0. Joining these 2 points, observing the second inequality in the question, that is x plus y greater than or equal to 5. By substituting x equal to 0, y equal to 0, we get 0 is greater than or equal to 5, which is false result. Hence we need to shade away from the origin. And next we need to consider, that is 0 comma 3 and 6 comma 0. Joining these 2 points, observe third inequality in the question, x plus 2y greater than or equal to 6. By substituting x equal to 0, y equal to 0, we get 0 is greater than or equal to 6, which is again a false result. Hence we need to shade away from the origin. Now a third equality in the solution, or first inequality in the question, that is x equal to 3. X equal to 3 is nothing but a line which passes through a point 3 and parallel to the y-axis. Observing the first inequality in the question, when we substitute x equal to 0, which is 0 is greater than or equal to 3. Hence we all know that which is a false result. Hence shading away from the origin. Therefore here yellow region shows a common region or feasible region which is unbounded. Let us solve the equations of lines. Consider x equal to 3 and one more line equation is x plus y equal to 5. On solving we get y equal to 2. Therefore a of 3 comma 2. Here is a point a of 3 comma 2 which is a corner point, and by solving x plus 2y equal to 6 and x plus y equal to 5, we get y equal to 1 and x equal to 4. Hence b of 4 comma 1, which is here b of 4 comma 1 is one more corner point. Therefore a, b, c are the three corner points of the given LPP. Consider a table: a of 3 comma 2, b of 4 comma 1, c of 6 comma 0. When a of 3 comma 2 we get z equal to 1, b of 4 comma 1 we get z equal to minus 2, c of 6 comma 0 we get z equal to minus 6. Therefore here 1 is, by observing the table we can say that 1 is the maximum value, but since the graph is unbounded graph, therefore considering a given z as minus x plus 2y greater than or equal to 1. Why? Because since the graph is unbounded graph, therefore 1 is may or may not be the maximum value of the given programming problem. Therefore minus x plus 2y is equal to 1. Find the values of x and y. When x equal to 0 we get y equal to 1 by 2. Here is a point 0 comma 1 by 2, and when y equal to 0 we get x equal to minus 1, that is minus 1 comma 0. Let us join these 2 points. Consider the inequality, that is minus x plus 2y greater than or equal to 1. When we substitute x equal to 0, y equal to 0, we get 0 is greater than 1, which is a false result. Hence we shading away from the origin. Therefore there are infinitely many common points between feasible region and the shaded region minus x plus 2y greater than 1. Hence there is no maximum value of the given linear programming problem. Let us see the next problem. Solve the LPP graphically. Minimize z equal to x plus y subject to the constraint x minus y less than or equal to minus 1, minus x plus y less than or equal to 0, and x comma y greater than or equal to 0. Here our objective function z is to minimize, and the constraints are x minus y less than or equal to minus 1 and minus x plus y less than or equal to 0. Let us see the solution. Consider the equality x minus y equal to minus 1. Find the value of x and y as, when we substitute x equal to 0, y equal to 1, y equal to 0, x equal to minus 1. Now we need to consider second inequality, minus x plus y equal to 0. Hence when we substitute x equal to 0 we get y equal to 0, and when y equal to 0 x equal to 0. Hence here we need to consider an arbitrary point, that is x equal to 1 we get y equal to 1. Therefore consider the xy plane. First point is 0 comma 1, next point is minus 1 comma 0. Joining these 2 points and observing the first inequality, x minus y less than or equal to minus 1. Substituting x equal to 0, y equal to 0, we get 0 is less than or equal to minus 1, which is a false result, hence shading away from the origin. And next points are 0 comma 0 and arbitrary point is 1 comma 1. Joining these 2 points. Here consider a point which does not lying on the line joining 0 comma 0 and 1 comma 0. Consider 1 comma 0. Substituting x equal to 1, y equal to 0, we get minus 1 is less than or equal to 0, which is a true answer, hence shading towards the origin. Therefore you are observing that there is no common shaded region. Hence if there is no common shaded region, hence we can't find the minimum or maximum value of the given linear programming problem. Hence this solution problem has no solution. Therefore, the given LPP has no solution. Thank you.